Welcome to Pavinar's webinars for the pavement community. My name is Andrew Bram, and today we'll be talking about tack coats for flexible pavements. So what we'll talk about today in particular is a little bit of background. We'll start with what is a tack coat and a little bit of the history of tack coats, and then we'll finally cover the importance of tack coat. We'll then go into the different materials of tack coats. This includes asphalt emulsion, also known as emulsified asphalt, hot applied asphalt binder, and reduced tracking tack coat. For design practices, we'll focus on dilution and application rate, and then we'll go over a couple of AASHTO resources as well. Then finally, for construction, we will cover 6 specific areas, including storage, equipment, surface preparation, weather and application, and then quality assurance. So what are tack coats? According to the FHWA, the Federal Highway Administration, tack coats are a sprayed application of asphalt binder on either an existing flexible or rigid pavement, and the flexible pavement may be milled, and there is fresh asphalt placed after the tack coat. So you can see in the picture on the right, that is a milled pavement surface. It's probably a mill and fill, where they mill off 2 inches of asphalt mixture. They sweep the surface, they place the tack coat, and then they place a fresh layer of asphalt mixture on top of that. And there are 4 types of tack coats. There are conventional hot applied asphalt binder, conventional asphalt emulsion, reduced tracking hot applied asphalt binder, and reduced tracking asphalt emulsion. And at the end of the day, what a tack coat does is it bonds the asphalt layers together. Now, I'm a pretty big fan of history, especially history of pavements and pavement materials, and the oldest book I currently have are Asphalts and Allied Surfaces by Herbert Abraham in 1918, and this is the 4th edition, so maybe someday I'll be lucky enough to obtain the 1st edition. But Abraham defines tack coats as the application of bituminous material intersposed with gravel, sand, or stone chips. So this is almost more of like what we consider today a chip seal / slurry surfacing type application, but this is how it was defined in 1918. Now, Volume 2 of AAPT, the Association of Asphalt Paving Technologists, Ross in 1929 defined tack coats as a comparatively light, cold application bituminous material that cures quickly and leaves a residue of semi-solid asphalt. And this is a little bit more along the lines of how we define it today, but if you were to do a full literature review on tack coats, there are literally hundreds, there are probably thousands of research projects since 1929 and that definition that Ross provided in AAPT. Now, some of the recent highlights are NCHRP Report 712. This is by Louay Mohammed down in LTRC. And what they did is they quantified the bonding between layers, both in the lab and the field. Excellent, excellent report. NAPA, the National Asphalt Pavement Association, they have a QIS 128. This was written by Dale Decker in 2018. And this is the best practices for emulsion tack coats. NCHRP has another document, this time a synthesis. It's 516 by Danny Gerhardt and Johnson. And this is both specifications, materials, and construction practices all in one. Again, a very nice, high-quality document. And then NCHRP Report 2006. This was put out by Musselman et al. In 2020. And this is methods for addressing tack tracking. All these are available online. I believe the NAPA document is free. I might be mistaken about that, but definitely the NCHRP documents and the NCAC document are free of charge. You can simply search those report numbers. And then also finally an NCHRP research report. This is put together by myself, Ding-Xin Chung, and Gary Hicks in 2022. And this is the proposed guidance for the construction of slurry seals, scrub seals, and tack coats. And that is a document that is available free online. And the tack coat section covers a lot of what we'll talk about today. It also has an excellent slurry seals and scrub seals section. So why do we even put tack coats down? Well, asphalt mixtures are placed in what are called lifts or layers, and these are anywhere from 1/2 inch to 3 inches thick, and we need to literally glue those layers together, or those lifts together. And the glue is the tack coat. And once you glue these layers together, you have the full pavement structure activated. So there's videos on YouTube that show the benefits of gluing wood 2x4s together. And this is a very, very similar concept where if you have a tack coat, you're able to activate all those layers into one large single layer. Whereas if you do not have that tack coat, essentially you have a bunch of plates stacked up on each other and they all act independently, and you get a lot more deflection and you don't get the strength that you designed for in your pavement structure. Now you can also glue an asphalt overlay to a rigid pavement. So asphalt mixture plus tack coat on top of a rigid pavement. And then you can also glue maintenance treatments to flexible and or rigid pavements. And this includes slurry seal and microsurfacing. Those combined are called slurry surfacing. Ultra thin bonded overlays and thin overlays. These all need to be glued to your flexible or rigid pavement surface. Now for tack coats, what type of materials are used? And we'll go into that in some more detail. We'll transition from background to materials. So as I mentioned, the 4 types of tack coat materials are a conventional hot applied asphalt binder, a conventional asphalt emulsion, and then also reduced tracking, both hot applied asphalt binder and reduced tracking asphalt emulsion. Now you may hear cutback emulsions being used here and there, but they're really rarely used these days, and that's because if you notice, what all of these technologies are doing is they're reducing the viscosity of asphalt binder. You can heat the asphalt binder to reduce the viscosity. You can make an asphalt emulsion to reduce the viscosity, or you could add a diesel fuel or some sort of cutback to reduce the viscosity. But of course, then you'll have emissions associated with that cutback, and therefore they're not nearly as popular as they once were. So we're just going to focus on the hot applied and the asphalt emulsion, both conventional and reduced tracking. So for conventional hot applied asphalt binder, you have to heat the asphalt binder to greater than 300 degrees Fahrenheit, and that's to get that viscosity down. Some of the advantages are it cools very quickly, there's very little tracking, this leads to less delays and using a reduced quantity of material. Some of the disadvantages include safety. You are spraying something on a pavement surface that's 300 degrees Fahrenheit or higher, and you can imagine all that's going through pumps and pipes and such, so there is safety involved with that. You need to have a higher energy cost to heat that material and to keep it heated. And also, if the material starts cooling down, it does take time to reheat the material. Generally, hot applied asphalt binders are just a performance grade binder, anything from a PG 46-28 to a PG 76-22. And generally you use the lower grades, the lower end of that spectrum in the more northern climates, and they can also be used in night paving in the southern climates. Now, what about asphalt emulsions, also known as emulsified asphalt? Well, let's talk about some terminology for conventional asphalt emulsions. There's 5 critical terms according to the Asphalt Institute. The first is the original emulsion, and this is undiluted emulsion, which is simply binder plus water plus emulsifiers. There is diluted emulsion, which is the original emulsion diluted with water, and it's usually diluted 1:1, so 1 part emulsion, 1 part water. And please note that the water needs to be added at the plant. If you're diluting an emulsion, you should not do that in the field. There is the term residual asphalt, and this is the remaining asphalt after the emulsion sets, and this is anywhere between 57 and 70% for an original emulsion, and diluted emulsions will see about 2/3 of that number. The tack coat break is where the water separates and the color turns from brown to black. And then the tack coat set is where you only have the residual asphalt left and there is no water. So original emulsion, diluted emulsion, residual emulsion, residual asphalt. Those are 3 terms for the material itself, depending on what state it's in. And then as the emulsion goes through flocculation and coalescence, it breaks and it sets. So what are the different types of asphalt emulsion? Well, there's 3 categories. We have AASHTO M140, and this is simply emulsified asphalt. AASHTO M208 is cationic emulsified asphalt, and cationic emulsified asphalt or cationic asphalt emulsion has positive charges that are preventing the asphalt binder droplets from joining together, as seen as that image. And then AASHTO M316 is polymer modified emulsified asphalt. Now you'll notice that there is no standard for anionic emulsified asphalt, and that is because those all fall under AASHTO M140, but there are other types, for example, non-ionic asphalt emulsions that are also under AASHTO M140. But M208 is cationic only, M316 is polymer modified only, and M140 is pretty much everything else. There are 4 reactivities associated with asphalt. There's rapid set and then medium set, and medium set does have high float. There is quick set and rapid set including high float, and I apologize, there's a mistake on the slide. That first bullet should read slow set and then medium set, quick set and then rapid set, and medium and rapid set include high float. You have low and high viscosity, you have high and standard asphalt binder, so that has to do with penetration, and you can have with solid polymer or latex to polymer modify it. And there are some states that have specialty emulsions such as FS-1, CRS-3, CQS-1, NV, PET, so you can see it's a whole alphabet soup of different types of asphalt emulsions. Now this is a very broad overview, and I encourage you to watch Introduction to Asphalt Emulsion. It's a Pavinar that was put out June 25th, 2021, which has some more detail, and I guarantee you there is not an error about the reactivities. So again, the 4 reactivities are slow set, medium set, quick set, and rapid set. And I apologize, I'm not fancy enough to cut the video and splice it together. I know that's capable, and my nieces and nephews can all probably do it with no problems, but I just push through and hopefully y'all know what the 4 reactivities are. Slow set, medium set, quick set, and rapid set. Now, for reduced tracking, this applies to both hot applied and asphalt emulsions. So the primary issues with tracking or tack on tires is there's no more tack between lifts. So you need that tack to glue the layers together. If that tack is gone, the layers aren't glued together and you're not going to get your full structural activation. So that's one problem. The other problem is that excess material, it goes somewhere else. So if it gets picked up on tires, it'll get put down on a roadway somewhere else, and that'll just create a mess. It won't look very nice, and you'll get a lot of drivers complaining. Now, some of the advantages of reduced tracking tack coat is obviously you have reduced tracking. You may hear the term trackless tack. The industry is moving away from that because all tacks track at some level, and we're just trying to minimize it with reduced tracking. Other advantages are shorter cure times and an increased bond strength. Some disadvantages are there is some tricky handling associated with the material, especially if you're used to just using the conventional types of tack coat. There's a necessary break time. So there's a very certain window there, a very specific window, and then also the cost. It is more expensive. Another thing that's a little complicated with reduced tracking is there are dozens of proprietary materials out there. It often has to do with zero pen asphalt binder, polymer modified asphalt binder. It can be hot applied, it can be asphalt emulsion, but really it's kind of the Wild West, and it's still an open area. So this is still something we're trying to get our heads around. Maybe in 5, 10, 15 years, I'll have a whole Pavinar on reduced tracking tack coats. Maybe we'll have a much stronger understanding of the ins and outs. All right, so that's a brief overview of the materials. Now we'll go into the design. So there are 2 primary topics that we're going to talk about. We're going to talk about the dilution for emulsion, and we're going to talk about the application rate. And really, even when you just look at these 2 bullets here, there's little consensus across literature in different states. So this is going to be kind of fun because we're going to hone in on what some specific states do, because they all have a little something different. They all have their idiosyncrasies. So let's start with dilution. Now, why do we dilute? Well, that additional water adds volume, and what happens is you enable the distributed to move more slowly, and this allows for your emulsion to flow easier and have a more uniform application. You want a very thin, very uniform application of asphalt emulsion. Now, some key considerations are you need to track the residual application. At the end of the day, it doesn't matter how much diluted asphalt emulsion you're putting down. What you really care about is the residual application amount, how much asphalt binder is left after the water leaves the system. And remember, I said this before, I'll say it again, dilution should be at the plant. You should not dilute asphalt emulsion in the field. Some potential issues include curing time being extended. The dilution does impact the application rate. It makes it a little trickier to determine just how much material you're putting down, and you need to put more of it down. And finally, some emulsions should not be diluted. For example, I read text about polymer modified emulsions should not be diluted, reduced tracking should not be diluted. I can pretty much guarantee that there are some proprietary products out there that are polymer modified that can be diluted. So these are general statements that those two types should not be diluted. Now, I did want to point out one thing also. Dilution has been going on for a while now, and applicator technology, distributor technology has gotten a lot better over the years. So there has been some discussion that dilution is no longer necessary because distributors can maintain a very low, very consistent speed with an undiluted emulsion and still get that application rate. So again, there's kind of some things that are moving here, and it really depends on what type of equipment you have, what type of material you're using, all those type of things. Now, there is some interesting variation among states. So for those of you who are Doug DeMuro fans, I absolutely love watching his videos, and actually this term may be copyright. If it is, Doug, I apologize. I will be happy to talk with you about how to handle that. But what are some quirks and features for dilution? Well, according to NCAT report 20-06, 26 states in the United States allow dilution, 16 specifically do not, and 8 are unclear. Some specific examples: in California, in cooler temperatures, you want to have a 0.5 to 1.0 dilution rate, so 0.5 water, 1.0 emulsion. In warmer conditions, you want a 1-to-1 dilution rate. In New York, only medium and slow setting asphalt emulsions can be diluted. In Ohio, you dilute materials until you have greater than 20 sabal second viscosity. In South Dakota, dilution should be done with potable water. They're very specific about this, but I actually agree with it. And in Utah, the dilution better controls your distribution with low application rates. So when you get down into the real low application rate, like 0.03 gallons per square yard, that's when dilution kind of kicks in. Now, if you have trouble sleeping, I encourage you to download all 50 state specifications, or all 51 if you want to look at District of Columbia, all 52 if you want to look at Puerto Rico. But I encourage you to download all state specifications because they all have a section on tack codes. 100% of the states have a section on tack codes. And it is very interesting because there are even more interesting statements than these. And it's just kind of fun to compare the similarities and differences and try and understand a consensus about what's going on. Now, what are some recommended application rates? Obviously, this has to do with the existing surface. So you can have new asphalt, old asphalt, a milled surface, Portland cement concrete. Then you got brick, vertical surfaces, some sort of interlayer, microsurfacing. You got all sorts of existing surfaces. And you can recommend application rates for the residual asphalt emulsion. And you can see here for new asphalt, that's the lowest. For old asphalt, you need a little more. For milled surfaces, you may need a little more, a little less, and so on and so forth. And then we have undiluted and diluted as well. And you can see here, new asphalt potentially could have 3 different application rates, whether you're calculating it based on residual asphalt emulsion, undiluted asphalt emulsion, or diluted asphalt emulsion. And you can see this dilution is just a 1-to-1. So if you had a 0.5 to 1, you would have even a different rate. So lots of things going on here, but basically the newer, the tighter the surface, the lower the application rate. That's kind of the big takeaway here. The second big takeaway is that there's a range. There's no one single right answer. And I compiled this for the NCHRP report from multiple sources, and there's multiple ranges. So let's dig into some very specific applications and some very specific sources. So let's compare FHWA and NCHRP to NAPA. You can see here NAPA has tighter recommendations. FHWA for new asphalt has 0.02 to 0.05, where NAPA has 0.03 to 0.04. It's a tighter on both top and bottom. For an existing or an old asphalt surface, it's a little tighter on the top. For the milled surface, it's a lot tighter on the top. And then for the Portland cement concrete, it's a little tighter on the bottom. So there's really no consistent trends except that NAPA has tighter guidelines for application rate. So this is an example of three very respected sources. I'm not saying one's right and one's wrong. It's the nice thing about being an academic is you don't have to say one is right or one's wrong. But I just wanted you to know that FHWA and NCHRP have different recommendations versus NAPA, and it's consistently different. But it also made different based on what asphalt mixture you're placing on, or what asphalt mixture you're placing it on. So, or excuse me, not only what asphalt mixture you're placing it on, but what asphalt mixture you're placing on top. So for example, in California, Caltrans has different application rates based on if you're using a dense graded overlay or an OGFC, which stands for open graded friction course. And you can see if you're using a dense grade, you need a little less asphalt emulsion. If you're using an OGFC, you need a little more asphalt emulsion. So it's also dependent on what mix you're placing on top. So this is all great. There's a lot of variables and it depends on a lot, but you can see there's a lot going on here that we need to take into consideration. Now, luckily, AASHTO has two very strong resources. The first is MP 36-18, which is materials for asphalt tack coat. And that P right there says it's a provisional standard. I would assume in the next couple of years, it'll probably be a full standard, so it'll just be M something. But if you search for materials in asphalt tack coat, a couple of years from now, you'll probably be able to find the proper AASHTO standard. Just make sure to use 2 A's instead of 3 A's when you are Googling AASHTO. So AASHTO MP 36 has emulsified asphalt. It calls out M140, M208, and M316. It has hot applied asphalt, which is PG grade. You use either M320, which is the standard super pave binder grading, or M332, which is Massacre, MSCR. It also talks about this concept of special purpose tack, which should follow a local agency standards. I believe this is what they mean by reduced tracking. So they call it special purpose. It can also be reduced tracking. For slow set emulsions, they recommend you dilute it 1-to-1 unless otherwise stated on your job. And they recommend not diluting quick or rapid setting emulsions. Now, on the other hand, AASHTO PP93, which is another, it's a practice and it's provisional, but it's talking about the actual design of it. But it has its own unique residual, undiluted, and diluted application rates. So I went through those tables on the previous slide. AASHTO PP93 has its own table with its own application rates, and it is not identical to anything we saw, but it's certainly in the ballpark. They recommend using asphalt emulsion when traffic is less than or equal to 5,000 ADT day or night. And they recommend using hot applied or special purpose when ADT is above 5,000 at night, or if you have a less than 8-hour time window during construction. And it's really nice because PP93 does have some examples of converting between residual to the actual asphalt emulsion rate. So if you have some questions about how to take an asphalt emulsion rate and convert it to how much residual asphalt emulsion residue you have, they have some nice examples in there, which is a really nice feature. Now, I also wanted to call out, this isn't directly associated with tack coats, so there's actually 3 that I think are useful, but AASHTO TP115, this is a test procedure, and it's determining the quality of tack coat adhesion to the surface of an asphalt pavement in the field or the laboratory. And this actually came out of LTRC, Louis Mohammed's NCHRP study, and it is a shear test, a guillotine test, that tests the quality of tack coat material and the appropriateness of tack coat application. So very nice resource, very interesting to look at. Now, finally, the construction. I apologize, this Pavinar is a little longer. Tack coats is a very big topic, but we're in the final stretch here for construction. So there are 6 important aspects of construction. You have to store the material, you need the equipment to place it, you need to prepare the surface, you need to consider the weather, you need to actually apply the tack coat, and there is quality assurance to consider. So let's walk through all 6 of these aspects. So for storage of the tack coat, long term you put it in a tank like you can see on the right. Shorter term you can have it in a tanker truck or a distributor. You do need to agitate your tack coat every 2 to 3 days, your tack coat material. And you want it stored at about 50 to 140 degrees Fahrenheit for all but rapid set high viscosity. And for rapid set and high viscosity, you want it a little warmer at 125 to 185 degrees Fahrenheit. And now, just so you know, if you have your tack coat in a tanker or a distributor, based on what time of day it is, you can see a fluctuation of temperature between 10 to 20 degrees Fahrenheit. And that's just because you don't have a whole lot of volume. You do not want it to sit in a tanker or a distributor for more than 48 hours. You also do not want to excessively pump your asphalt emulsion. So you don't want to pump it into a truck, off of a truck, back into a tank, back into a truck, back into a tank, blah, blah, blah. Excessively pumping it does degrade the asphalt emulsion. You do not want to agitate it with forced air. You want to have mechanical stirrers to stir your asphalt emulsion. And you never want to mix incompatible asphalt emulsions. You never want to mix a anionic with a cationic emulsion, for example, because they'll immediately break and you'll just be left with a mess in your tank or in your truck. Now, also good practice is you want to clean all your tanks, trucks, and hoses and pipes at least once a year. More obviously is preferable, but this just prevents material from building up and compromising the quality of the equipment that you have. Now, what sort of equipment do you need? You need brooms. You want to clean the pavement before your tack applications. There's really very little guidance about how to keep your brooms in good shape. There is some discussion about bristles being a proper length and the bristles being clean, but you need a clean surface and you need a broom to achieve that. Some people use spray wands, and these are used in areas that are not accessible to a distributor. You want to make sure that you're applying the same even application. This is very difficult to do by hand. Some people are extremely good at it. Some people are not as good at it, but you do want to aim for the same even application. Another piece of equipment, more specialized piece of equipment, is a spray paver. And this is where you have a spray bar that is immediately before the screed. The nice thing about this is you have no tracking because the tack coat goes down and immediately the asphalt mixture is placed on top, so there is zero construction or other traffic going on that tack coat. And you can also improve compaction. However, it is more expensive. It's a specialty piece of equipment. There's a relatively small storage tank on the spray paver itself, so that needs to be refilled relatively frequently. And it's difficult to check the application rate and the quality of the tack because it's all in one machine. You can't just look at it and say, oh, that nozzle's out, that nozzle's clogged, because it's all hidden kind of inside of the machine. And then finally, the most common piece of equipment people think of is the asphalt distributor itself. You have a tank, a heating system, an asphalt pump, a circulating system, a spray bar, a flushing and clean out system, a power system, you need metering, and the chassis to move everything around. So asphalt distributors are pretty comprehensive. There's a lot of moving parts there that need to be taken care of. And assuming everything's working out, you want to make sure that it's calibrated correctly and the nozzles are clean and the same size and they are oriented in the correct angle. Now, when we're preparing the surface for the tack coat, this is absolutely essential. You do not want to skip over proper surface preparation. Now, I've said multiple times in this Pavinar that literature is not all on the same page, or there's different points of view, or everyone's got something a little different. There is no disagreement across literature. You must properly prepare your surface. So now that we've established that surface preparation is important, you want to make sure it is clean. There is no dirt, there is no dust, there is no vegetation. You want to fill all cracks greater than a ½ inch. You want to level all depressions greater than 1 inch. Now, preparation is important, but it is not necessarily consistent. One of the things people are not consistent above is moisture. FHWA states you need a dry surface. NAPA says you can have a small amount of moisture. If you can define small amount for me, I would appreciate it. I would assume standing water is not a small amount because a lot of states prohibit tack coat application on standing water. I would agree with that 100%. But can it rain? Is it damp? Is it just spotty? I don't know what small amount is, but NAPA says you can have it. Now, I do also want to say excess tack coat is not a substitute for a clean surface. If you have a dirty surface, you can't simply throw more tack coat on there. That will not work. It'll create a slip plane. The tack won't behave properly. It may bleed up into the surface. So you need to properly clean the surface, and the surface structure must be properly prepared. Now, for weather, we're going back to consensuses are difficult to find. So let's go through some examples. In the state of Alabama, you can see here, this is actually a really nice map I found. It took a little bit of time, but Alabama's specifications specifically talk about north of 33 degrees north and south of 33 degrees north. So this map of Alabama had 33 degrees north labeled clearly, which is the red line that I emphasize. So if you're north of there, tack can't be applied from October to May. If you're south of 33, you can apply it in October and in May, but you can't apply it November through April 1. So I guess those cities right there on the border, for example, Tuscaloosa, man, if you guys were like 10 miles further south, you could have 2 more months of tack coat application, but I guess you are out of luck. Montana, the ambient temperature must be 50 degrees Fahrenheit and rising, and the surface temperature must be 35 degrees Fahrenheit and rising. So it's kind of interesting here, difference between ambient or air temperature and surface temperature. Utah has a very interesting statement here. They agree with Montana. The ambient temperature should be 50 degrees Fahrenheit and rising. They require a dry surface, so they are in the FHWA camp. But they also have viscosity requirements. So they have a required viscosity between 50 and 100 centistokes, and that's according to AASHTO T201. So that's unique. As far as I could see, that is the only state that has a viscosity requirement for tack coats during application. So that's something that's pretty interesting. And like I said before, as you're reading through about the design and other things, it's just fun to see what states do and what they do differently. Like, just for example, in this map, if you just read Mississippi, Alabama, Georgia, and Florida's tack coat specifications, those 4 states are all in the same place. You know, they're all right now, well, they're not in the same place, but they're all right next to each other. Very, very similar climates. They all have slightly different specifications. So it's just kind of interesting to explore that. Now, the application of tack coat, there are many facets. You may need to mill an existing pavement beforehand. You need to actually spray the material. You may put down paper joints in order for good, nice, clean lines between construction areas. You'll need to have traffic control. You want to make sure you protect motor vehicles. I do not know a single person who likes asphalt emulsion or hot applied asphalt being sprayed on their car. I love both. I don't want it sprayed on my car. You need to worry about the sequence of work and any sort of application of new surface on top of the tack coat. So there's a lot of things that you need to think about. I'm just going to go over some concepts here. The resources that I talked about earlier have a lot more details about all of these. So this is just a broad overview, but you can drill down deep into all these. So one of the things that people talk about is whether or not you should leave a milling surface open. Some of the pros to that is vehicles can help clean the surface and it provides flexibility for contractors. Some of the cons is there is an increased risks from motorcycles. There are potential drainage and structural issues, and it's also a little noisier. Another con, they're actually leaving the milling surface open here in Fayetteville on College Avenue. They're doing a really big job. A huge con is a lot of cars, including myself, don't feel as comfortable driving over a milled surface. So there's a lot of strange lane changes, a lot more traffic in the lane that is not milled. So kind of traffic flow and driver considerations is also another con, in my opinion. But I do admit that the surface is very clean, and the contractor who's only working at night has a tremendous amount of flexibility. So they are getting those pros. There's a lot of characteristics about the distributor that are important. This includes the speed that you're moving, the bar height, how high the spray bar is off the pavement surface, the pressure, how much pressure is forcing the emulsion through the nozzles, and then your nozzle type, the angle of the nozzle, and the configuration of the nozzle. All these are very important for the actual application, making sure you're applying enough. The temperature applying is based on the type and the grade, and for emulsions, those are down in the 70 degrees Fahrenheit, and then hot applied can get all the way up to 400. So it's a massive range, and it's highly dependent on the materials. Usually emulsion is in the 70 to 150, 180 degrees Fahrenheit, and hot applied is in the 300 to 400 degrees Fahrenheit. But it's a big range based on what you have. You must track your application rate, so how much you're putting down. There's a lot of different ways you can do this. You can do it by volume of material being placed, you can do it by weight of material being placed, or you can directly measure it by taking a sample out of a nozzle with a little plastic container, put a pad down on the road, a lot of different options there. And then finally, for traffic control, our friend Manual of Uniform Traffic Control Devices, MUTCD, which is available free of charge to download online from FHWA, has over 800 pages of information about traffic control. So it's everything you need. Very interesting resource. And then, of course, if you drill down into a state-by-state basis, there are many interesting statements like the other areas we've covered based on application, which I will not go over here, but I will let you explore at your leisure. Now, finally, quality assurance for tack coat. It's important to sample correctly. You need to follow AASHTO R66. The materials that you're using and how to properly capture the quality of your materials. There's AASHTO R42, R66, R77. You need to make sure your equipment is calibrated. That's ASTM D2995. For agency acceptance, they often use the plate method or a yield calculation. And also some states are moving toward a tack coat strength test. So this goes back to that LTRC work about the guillotine test or the shear test to measure tack coat quality and quantity. Some states actually are requiring a tack coat strength test, including Kansas, not surprisingly Louisiana, Alabama, Oregon, Texas, and Virginia. And then tracking is very important. This is a very famous picture from Dr. Randy West at NCAT. This is exactly what you do not want to see, which is a beautiful tack coat that is placed and that is being picked up and carried away by that truck sitting there that probably has asphalt mixtures in it and the paver is just to our left. But that is an area where the pavement will not properly apply to the, or will not properly glue to the existing road, and it's right in the wheel path, so you're probably going to have problems down the road. Anyway, but to address tracking, you need driver training. If you're using a material transfer vehicle, you can consider placing that in the adjacent lane. That will reduce a lot of traffic on the lane that you're paving. You can consider reduced tracking material, spray paver. You can reapply if there is a lot of tracking. There's a whole lot going on there. Now, something that is worth noting is that tracking will occur on some level on every job, and the question you have to ask is, what is acceptable? Now, luckily, this is more of informational, and that what is acceptable is up to the owner. What do they think is acceptable? And there's a huge amount of variation. So quality assurance is a fast-moving area. This is something that's gotten a lot of attention recently. So again, keep your eye on this. This is very important. The intent is 100% good. We're trying to get a better material out there. But the implementation is not set, and it is fast moving. So keep your eye on this as we move forward. So as a summary, we talked about a background of tack coat, we covered the materials and the design, and we finished up with some construction. So thank you very much for joining me today, and I hope you have a wonderful day.